Good morning and welcome back to Serial Science. It's bite-sized science for the curious. So every week we have an awesome science guest and we sit them down and ask them a whole bunch of random questions. So fire up your questions. We have been on a real space theme lately. So last week we talked to Natalie Follett from the Institute for Research on Exoplanets. And this week we have Rachel Wang, and Rachel is the astronomer at the McMillan Space Center in Vancouver. So good morning, Rachel.
Good morning.
So we are been talking a lot about superheroes and comic books, and there's a big space tie-in there because so many of our superheroes kind of get their power from space, or they come from space, or like they do mighty battles in space. It's always the theater of space. So I wanted to talk to you about some space stuff. So I'll kick us off. We had talked a little bit about this. So Superman gets his powers from the sun of his home planet. And that's kind of like an interesting, origin story and an interesting battery pack for sure.
Well, he essentially is like a solar battery or even like a plant that soaks up energy from the sun. I like to think of it as like almost drinking up radiation or drinking an energy drink from the sun.
Totally.
And what's kind of interesting is that he actually gets different amounts of power based on the kind of star that he's near. So for us, we have a yellow star. And for him back at home, he has a red star, and red light has a little bit less energy than yellow light does. So I like to joke that when he's back on his home planet, he isn't Superman, but he's kind of a regular man.
He's just average Joe.
Exactly, yeah. But then all of a sudden it comes to Earth, there's a slightly different color for the star near us, and he gets a little bit more energy that way.
That's crazy. So it's because he's a tourist, basically, that he's got all this, leap over tall buildings and
yeah, kind of.
fly.
He's like a space tourist, yeah.
And one of the things that he can do is like he can fly, he can leap off tall stuff. Like, is he affected by gravity in the same way, or it's just that he's got this extra superpower?
So it's a little bit to do with his strength from the sun, but also because of that difference in gravity. So if he were to go to a different planet, let's say he went to Jupiter, which has around twice the gravity that we have here on Earth, and he tried to jump over, let's say, the Empire State Building or even the CN Tower, he wouldn't even make it up halfway. But if he went somewhere with a little bit less gravity, let's say maybe like Mars, which has a third of Earth's gravity, then he could probably jump over two of them stacked one on top of the other. So, but you can also get those kind of superpowers too, like if you went to the moon, we often see astronauts on the moon leaping and bounding with these gravity. So technically, if you went to a planet with low enough gravity, you could also do that super leap that Superman does.
You could also have those superpowers from being a tourist and being on a different planet.
As easy as that.
That's awesome. And so we do have some real life superheroes. We have our astronauts who are up above us on the ISS on, prepping for missions, going on missions. And and your background is astronomy. And I read in your bio that it is your dream to be a CSA astronaut.
Yes, I would love to, but I think that my main hindrance is that I get a little bit claustrophobic. So being stuck in the equivalent of a 6-bedroom house in space for a prolonged period of time, I might need some training for. So maybe we'll start with some on-Earth analog missions before they send me up into the ISS.
But what is an analog mission? What does that mean?
So it's almost like a practice makes perfect kind of idea where because sending people to space is very, very expensive. And we want to make sure that when we're risking human life, we want to make sure that everything is perfect when we go. So we do things called analog missions on Earth where we look for places that have extreme environments that are similar to the environments that astronauts would encounter in space. And we kind of put them through the ringer of what they would experience. So things like long distance communication, being confined in a space. And we do this for rovers as well, going to places like the Atacama Desert to simulate going to Mars and roving around on Mars, and just to make sure that we're all ready to go when we actually do go on that mission finally.
Totally. And I can see testing out like your vehicle, you want to drive it on all the rough terrain, but like how do people prep for this? Like where do you go to be in space boot camp?
It's a lot of dry places. We even have people going underwater as well. So Chris Hadfield actually was part of this AUV testing. So it's an underwater automated vehicle. And so what he did is he went into this contraption, almost like a submarine or a personalized one-person submarine.
Like a tiny little pod, like a...
Yeah, exactly, with like windows and everything. And he went
cool.
down and kind of drove it around, and he wanted to take data. And it's kind of interesting because, you know, when you're stuck in the submarine, it's a lot like when you're stuck in a spacecraft going in space. You know, you can't exit unless you're wearing the proper attire or equipment, things like a scuba suit or an astronaut suit that you have your life and oxygen attached to your back. But it's kind of interesting to see Chris Hadfield, who is a famous CSA astronaut who's been up to the ISS, do something like that and try communicating with people back on land, which would be the equivalent of astronauts communicating with people on Earth, and not being able to interact with your team directly and kind of being on your own for a mission.
For sure. How long did that last for? Like, that sounds really tough. Kind of like you're in this pod, you're underwater, you have people telling you kind of like, okay, pull this lever. You're trying to make it work. How long did that last for?
A few hours at least, because they do have a limited oxygen supply in this confined environment. But they do try to keep them in these environments for as long as possible, because you are in space for, you know, at least a certain amount of time before they can bring you back down. And so they want to really put them through that test and make sure that they can stay there for as long as possible.
And how do they test? So underwater, you still have gravity. Like, how do people test? How do you practice going up in space and like being on the floats and
that's a great question.
The moves where you go upside down?
How do you deal with the nausea that you're definitely going to experience on the ISS? And the way that they do it is they have training planes, training vehicles. And this particular one is very aptly nicknamed the Vomit Comet, because a lot of people...
I don't want to be an astronaut, actually. Yeah. I take it back. The Vomit Comet. So tell me about this.
Yeah, so Vomit Comet, but it's also a plane that goes on something called a parabolic trajectory. So what that really is they're going up and down like this continuously for a short amount of time. And so when they climb up and they reach kind of the peak, it's almost like the same thing that you would get in a roller coaster, where you kind of feel like your stomach goes up into your throat, and all of a sudden you feel a little bit weightless and a little bit sick at the same time. The same thing is happening here as they're going and falling down. So they get kind of that experience of that microgravity environment that you'd feel in space. And I say microgravity because there is that misconception that in space there's zero gravity everywhere. Yeah, but there's a tiny bit of gravity everywhere in space. And so when I say microgravity, it just means a small amount of gravity up there in the ISS as well.
The tiniest fraction. I really want to know who drives the Vomit Comet. Like, who is piloting that thing?
They must have to be very not
steel. Yeah.
At all. Yeah.
No, that might be a requirement for being that pilot. And so we have a question about Chris Hadfield and his underwater mission, his pod. So was he on the very bottom of the ocean? Is that a way that we could explore the ocean? Figure out what's actually on the bottom?
Oh, that's a good question. So he was actually in the bottom of a lake.
Oh.
And it's interesting to think of a lake as being an extreme environment where you'd run these analog missions, but it truly is, because if you think about it, you know, if I was to go underwater in the lake without any sort of equipment, I wouldn't last very long, because I absolutely cannot hold my breath for that long, and I'm a terrible swimmer. So in that way, it is an extreme environment where humans can't live there and sustain life underwater for that long. And this particular lake that they were going to actually is a local scientist that works at UBC who was going to this lake and studying things called microbialites under the water. And there are these organisms that exist in extreme environments all around the world. And so she wanted to conduct a bit of research that way. And so her project was very similar to conducting a project on a different planet, because you are going to that extreme environment and you're taking samples and conducting research in this environment.
Oh, that's super cool. So not only training for space, but training for research in space as well.
Exactly.
No,
Yeah, doing
that's
all the
super awesome.
procedures, because it is a lot different doing it off the planet than on.
Yeah, I bet. On the planet, you can, you maybe get a break every few months. You can
Yeah.
go see your family. The missions to like, how long is a space mission, or how long do we expect them to be when you'd be up on the ISS, or maybe going out to Mars? Like, what kind of time frames are we talking about?
So with the ISS, it's typically on the order of months, just because, you have to get up there, you get acclimatize, you get used to that microgravity environment, and then you conduct your research or do whatever you were sent up there to do, and then you come back down. We do have astronauts that have been there for over a year, and I very commend them for that, because I don't know if I could do that for that long. But if you're going to get somewhere a little bit further, let's say you're going to Mars, then it's a little bit more complicated, and that's because of the alignment of the planets in their orbits. We want to wait until they're the closest that they can be on the same side of the sun, rather than trying to launch a spacecraft to the other side of the solar system. It's a little bit more difficult. So the actual journey itself is from Earth to Mars is around 7 months, but then you have to wait for the planets to go around in their orbits, come back around, and then get back to that optimal configuration again. So we don't have to waste a lot of fuel sending people from Earth to Mars and back.
Cool. So very, very long missions, lengthy missions. So on the ISS, we send people up there fairly regularly. But and you mentioned people doing research and kind of going up for sort of different purposes. But like, what is a day in the life of an astronaut like on board there?
It's interesting that you say day, because the concept of a day on the ISS is a little bit of a weird one. And that's because, they're going around the Earth every 90 minutes. And that means that they're experiencing something like 16 sunrises and sunsets every day as they're going around in orbit. And so typically what a scientist would do, or a researcher would do on the ISS, is they get up from an alarm, they wake up in their sleeping bags that are strapped to the wall so they don't float away in the middle of the night.
They're just like stuck to it like a
exactly. And it's kind of cool to think about, because in space, orientation is kind of weird, up and down, side to side. It's all kind of mixed up. So astronauts are just as comfortable sleeping upside down than they are, lying horizontal.
There's no hanging sensation.
Exactly. So it's no difference. And I think that's always a funny fact to think about. But so they wake up from an alarm, they have breakfast, and that also looks a little bit different. Everything that you do working and living in space is so much different than you do on Earth, because you have to deal with things floating away. When you have things like food, you need to rehydrate your food.
Okay.
And have
no cereal up in space. No floating Cheerios or milk.
Yeah. Oh, so let's say that you brought cereal up to the ISS, and you'd have it in this vacuum sealed package, and you might have powdered milk inside, and you'd have a little nozzle at the top that you would have to inject water into to get your cereal. So it's a lot more work just to get that bowl of Cinnamon Toast Crunch, but it's well worth it on the ISS. But some other things that they do is things like conducting their research when they have time, or when there's a lot of time for it, and doing maintenance on the ISS. So that's when you see astronauts doing things like spacewalks. They're sometimes replacing batteries outside and just making sure that everything is okay and good to go still on the ISS. And then you'll also see astronauts doing physical exercise. And that's because, gravity does, or the lack of gravity does take a toll on your body. It acts on things like fluids in your body, things like water, your liquid distribution all around. And so they have to exercise to keep up things like your muscles and even bone density, like trying to counteract the effects of that microgravity environment.
And so how do you exercise in space? Like there's no gravity, so your big heavy weights, like they won't really weigh anything. You can, no push-ups or deadlifts or how do you train in space?
So they have a treadmill up there on the ISS that they can strap themselves into, or things like even a bike would also work as well. Because you're very right. If I was to deadlift on the ISS, I would be amazing at it.
Bench press 300 pounds, yeah.
Exactly.
Cool. So between exercise and maintenance work on the ship itself, and then research, that sounds like a very full day. Like, do they have like a required 8 hours of sleep? Like, do they have someone telling them it's their bedtime? Do they work in opposite shifts, so one person's sleeping while other people are awake? How do they arrange that?
Yeah, so their life is quite dictated by people here on Earth, and that's because of budgeting resources. So we do want to make sure that our astronauts are getting the amount of sleep that they need, so they're not sleepy and tired and needing coffee every morning to get themselves working like I do.
That's how I feel.
But they also have things like their dietary budget. So the amount of food that they can eat is strictly controlled by the wonderful people at NASA, because they can only send up so much food. So we don't want them to, binge eat in the first 2 months that they're there and then run out of food for the rest of their mission.
Very strict diet.
Exactly, yeah.
Cool. And so, like, do they have any downtime? Like, we've seen Chris Hadfield. He brought a guitar. He was playing. What do you get to do to relax as an astronaut? Like, you can't exactly go for a walk, but maybe, I don't know. Maybe just, I feel like I would just look out the window all the time.
For sure, that's definitely something that astronauts do quite a bit, and I would as well. Being able to see the Earth as the sort of overview effect that's often described by astronauts, like this incredible feeling of being able to see the entire world outside of your window on the ISS and seeing that curvature of the Earth and kind of having that sense of a global community all at once. And you can see almost kind of how delicate and fragile our little blue marble is out there in space. But besides admiring our Earth and the pretty views, they are allowed to bring up personal
every day.
Yeah, no, and honestly, they probably do take up time every day to do that, and I absolutely would if I was on the ISS. But they can bring up personal effects. So like you said, Chris Hadfield brought up his guitar. There's some lovely videos on YouTube of him singing on the ISS. I would highly recommend it. He's fantastic. But a lot of people bring up their own forms of entertainment. They also can record messages and send them to people back home and even socialize and chill out with the rest of the astronauts. There's some interesting people up there.
Totally, I bet. We got a comment from the floor about hopefully they get pizza. Maybe they can have a pizza party.
My coworker has a very funny story about the time that ISS astronauts ordered sushi, and and
how did this go?
I think they've also ordered pizza before too, but it was a very expensive delivery bill going up to the ISS. But when they ordered sushi, there was a problem because they had wasabi, and the wasabi, little bits of it broke off and actually ended up circulating in the air system because they were everything on the ISS. So the astronauts had a little bit of a spicy time afterwards.
If you've ever accidentally eaten a chunk of wasabi or got it up your nose, you get that really horseradish burning feeling.
And now it's in the air.
Oh man. So they actually had sushi delivered up to the ISS?
Yes, and I'm pretty sure they had pizza as well. I remember seeing a picture of a almost like a fake receipt of when they delivered a pizza to the ISS.
Really great tip.
Yeah.
Wouldn't the sushi go bad? How long? I'm so confused. How do you get sushi on the ISS?
So I'm imagining that they probably sent it on another resupply mission. When we sent Bob and Doug recently up to the ISS from US soil for the first time since the space shuttle program ended, that took around, I believe 19 hours. So almost a day for them to actually really get up and physically into the ISS and being able to greet everyone else there. And, and that's just because, there's a lot of technicalities and really make sure that when you're doing docking and having your docking procedure, that you're not messing anything up that's on the ISS already. So that's a very
careful landing
procedure for sure.
For sure. So we always talk about what people are doing. People are doing research, and there's probably some really awesome, cool discoveries that have come out from being out in space where you just can't predict sometimes. What do you think is the greatest space discovery we've gotten from a mission? The coolest thing that we've brought back that we've learned out there? Oh, I know, tough question. There's so much.
There's so much. I think one of the coolest things that I've heard recently is there was a new discovery about our moon. And I think that that's really incredible because, our moon is our closest companion. It's been around there for billions of years, but we're still learning new things about it. And what they found is they actually were looking for sources of water or ice water in the shadowy parts of craters. And they actually ended up finding something else when they were going to look for ice water. And they ended up finding a lot of metal in the south pole of the moon. And that was kind of weird because we didn't really expect there to be a lot of metal kind of that close to the surface. And
what kind of metal? Like, are we talking gold deposits here?
A lot of thorium and I want to say iron as well, but just metals that we weren't expecting to be there. And there was a hypothesis that, well, perhaps a metal-rich asteroid actually slammed into the moon and then just became part of the moon and deposited its metal there. But that was a recent new moon news that came out earlier this year. And it's just still mind-blowing to me that we're still finding out so many things about our moon and even about our sun, actually, with the Parker Solar Probe mission coming up as well.
Ooh, tell me about that. Where we're sending a probe to the sun. Like, what are we hoping to find? What are we hoping to learn?
So the Parker Solar Probe is our fastest traveling probe ever. The fastest it'll travel when it's near the sun, I think, is 200 kilometers per second, so extremely quickly. And so, like, I like to give the example of if I was, here in Vancouver, and then I went up to our local ski mountain, which is Whistler, which is, I think, 125 kilometers away. If I strapped myself to the front of the probe and flew there, it would take me just over a second to get there, which is incredibly quickly.
Almost instantaneous.
Exactly. And I wouldn't survive the trip for sure, but it's a fun hypothetical to think about. But we're sending the Parker Solar Probe, and it's on its way there to the sun now. And we're hoping that it'll go and take measurements of the sun's corona, or the sun's atmosphere. And the reason why this is so important is because this is the first time that we're sending a physical robot with scientific instruments to go and take measurements at the place at the sun, which we've never done that before. So it'll be really interesting to learn what more we don't know about our sun, even though it is our closest star to us, and we know a lot about other stars out there. It's interesting to see and learn about the one that is closest to us and see what else or what more we can uncover.
So are they going to land on the sun like that, or just kind of hover nearby? Like, how do you visit the sun?
So they'll fly through the sun's atmosphere, the sun's corona. And how they're going to do that is they are using the pull of Venus's gravity as kind of almost like a gravitational slingshot. So what they're going to do is, and they're doing it right now, is using Venus as a flyby. So they're going around Venus, using its gravity, slingshotting it, and bringing its orbit a little bit closer to the sun every single time it goes around. And it'll do this 7 times. And I think it's on its perhaps 3rd or 4th pass by, but it'll get closer and closer, and eventually slingshot itself into the sun, take measurements, and come back out.
Oh, it'll get back out?
Yeah, it'll keep going on this trajectory. And I actually have a short video that I can share with you with pictures of the highest resolution images we've ever taken of our sun.
And I think it's really interesting. Photo of the sun. Wow.
Yeah, so it's a movie. So here we go. So what you're seeing right now is just the highest resolution images put together as a video that we taken with the Daniel K. Inouye telescope last year in December. And it's incredibly interesting because you can see all the individual, what we call convection cells on the surface of the sun. And let me play a little bit of a closer up view of it.
It looks like a honeycomb almost, or like melted chocolate, or like Mr. Crisp bars.
Oh, now that you're saying that it looks like honey, I think that that's very true. And now I'm getting a little bit hungry, but I digress. So it's really cool because if you take a look at these cells, each one of these cells that you're seeing is actually the size of Texas.
What?
So it's huge, absolutely huge. I can show you a little bit of
that is wild.
Here. So this is the movie that we saw, and here is one of those cells being the size of Texas, which is absolutely crazy to think about that it's that big. But the reason why we get these convection cells that are the size of Texas is because the sun is constantly going through this process of convection. And convection is basically when we have that idea of hot air rising and cool air sinking. The same thing is going on here. Yeah, exactly. Exactly like a convection oven. And basically each one of these cells is its own separate convection oven. So they're bringing that hot material from interior of the sun, bringing it up to the surface, letting it cool off as it interacts with the coldness of space, and then it sinks back down. And it keeps doing this. And that's why you're seeing that lovely, almost turbulent motion here.
Yeah. Yeah.
Really, really cool. Yeah.
Kind of like cells almost. So what's the boundary? Like, is it just kind of a function of how hot stuff is how big it can get, and then it sort of is like a bubble on a stovetop of boiling water. It just kind of gets big enough and then it's done kind of thing, or
yeah, so it's almost like separate? That. One way to think about it is by thinking about sunspots. So sunspots are a little bit darker than the rest of the sun. That's because they are cooler, relatively cooler compared to elsewhere on the sun's surface. And the same kind of thing is happening here, where you have these boundaries that are a little bit cooler, and the boundaries are really from magnetic field lines, but I won't get too much into that. But it's basically these boundaries where it's a little bit cooler on these edges, and the same kind of thing that happens with sunspots, a little bit cooler, they look a little bit darker.
That's so fun. That's sweet. That's a really cool video. So that mission is ongoing now. So we're getting kind of these images basically right now, August 2020. So what are they hoping to get? Anything specific, or like is it mostly images that are they measuring? I don't know. You mentioned the atmosphere of the sun, and that was kind of interesting to me. Like, I know Earth has an atmosphere, but I don't picture the sun as having an atmosphere. I picture it as just kind of like a burning ball in space. So what is surrounding the sun?
That is a good picture to have, this burning ball in space. It's burning ball of hydrogen and helium floating out there, generating all of the heat and light that we get here on Earth. And the sun's corona, or what I'm calling the sun's atmosphere, is really this idea that you have extremely hot gases in this almost ring around the sun. And you'll see that when we have things like solar eclipse, when the moon comes in front, blocks off most of the sun, and you get these little tail, almost wisps, coming around the edges of the sun. And so what you're seeing there is actually the corona. And so there's just this kind of thin shell of really, really hot gas, and it's quite hot. I believe it's hotter than the surface of the sun, because you do have all of this energetic gases being heated and is going kind of all over the place.
Wow, that's cool. And so when we say corona, I believe that is a word for crown. So it has nothing to do with the coronavirus. It is its own thing. It's not related in any way. Cool. Well, that's awesome. We just have a few minutes left. So I wanted to ask, we talked about Superman and his power source, his origin story, his like solar powered battery pack. But for you, what's your origin story as a scientist? How did you get into astronomy and become the astronomer for the McMillan Space Center? Like what got you started?
It's actually kind of a funny story. So I visited the Space Center that I work at right now as a kid in elementary school. And I have very vivid memories of coming up in a school bus, and we have this big crab sculpture outside with a lot of water jets coming out, and going into the planetarium. We have a big dome there, and I have vivid memories of going when I was in elementary school. And then I ended up going to the University of British Columbia for a combined degree in both physics and astronomy. And then right after I graduated, I took some time off and kind of almost lived the pseudo retirement life for a little bit. And then ended up finding my way to the Space Center. And it was really almost like a dream come true for me, because I got to give back to the community, the same kind of community that gave me that initial, sense of wonder and just that kind of wow sense when I went to the Space Center. I was thinking about how much stuff is out there. And I like to make the joke that, the universe is so big that there is no shortage of thesis topics for me whatsoever. So it's, I don't know. And it's just the immensity of the universe, and the fact that we have all of these phenomena that we would never see here on Earth, and we can view them out in space. I think that is the most fascinating thing.
And we're just starting to be able to get there and to learn. It's just the beginning. So that's very
starting with, like, the first black hole picture, and we're just going to keep getting better and better.
No, it's super exciting. I feel like everything we talked about, I was like, really? Like, I didn't know that. Tell me more. So it's a super, like, space is such a huge topic, and there's so many cool things going on. It was really great to have you, and thank you so much for answering all of our burning space questions. So we are next week, we are actually doing a 180. We're going to go from space, and we are actually going to talk about sharks. So we have Dr. David Schiffman talking about sharks, bottom of the ocean, we'll go from space to the bottom of the ocean. So so it'll be a little bit of a switch up, but yeah, thank you so much, Rachel, and thanks everyone for watching.
Thanks for having me.